Hi everyone, this is Mr. Rowe here, back with a second video lesson that I'm making for you. I decided to do a little bit different this time. Instead of me filling out a note and talking through it as I do it, this note's already filled out and I'll just be talking through it and going through it. It's just that there was a ton of work that needed to be done to do this note, and if I did it the other way, it would have taken well over an hour. So this way it'll be a lot shorter for you, and it's gonna go pretty fast. I'm gonna keep the pace pretty quick, but because it's a video, you can always pause it, go back, rewatch, etc. And of course, after watching it, if you still have some questions, just reach out and I'll do my best to help. Okay, that being said, so we're completely changing gears from our last unit of trigonometry, and we're starting our quadratics unit. So you do have exposure of this from grade 10. So just as a reminder, this is a parabola. This is what the whole unit is about, a curve just like this. This note's also already been posted to the LMS as well. I'm going to be marking it up as I go along. I won't post that version of it, just the version that you'll see here. So this is a parabola. This is the basic parabola. So you need to know what I'm going to call these key points. I graphed this using a table of values. So what this means is I just picked these x values and I call this the standard set. It's -3, -2, -1, 0, 1, 2, 3. And you take the value of x, you plug it into the equation and see what y equals at that value. So when I put in -3 into here and then square it, I get +9. So that means that when x equals -3, which is right here, y is going to equal +9, and that becomes a point on my graph. So I did that with all these values of x in the standard set, and I got these values, and I plotted them. And when you graph them, you get a curve that looks like this. It's not a V shape. I tried to do my best because I'm just using a mouse, but it's more like a rounded. That's not a good example either. If you go to the last note, you'll see a really good example in the introduction to parabolas. But that's a pretty good one. And this opens up, and these arrows indicate that it'll continue to go up indefinitely. So from this, we can identify a couple of key points. One is the vertex. So if you went over the last lesson, we went over key points of the parabola, and this is the vertex. It's either the highest or lowest point of the parabola. Because this parabola opens up, this is the lowest point, and it is at the origin 0, 0. These arrows are pointing in the up direction, so this parabola opens up. And then I'm asking you for something that's called the step pattern. So this is what a step pattern is. If you know the step pattern, you can graph a parabola easily because it's going to tell you how to get to the next point. So if you start at the vertex, what this step pattern is telling me is if I move over 1, this first number tells me how much to go up. In this case, 1. The next step would be if I go over 1 again, I would go up 3. And that's how I would get to this point. And finally, if I move over, so you're always moving over 1. So if I go over 1 again, how many do I have to go to get to the next point? This is a +5. So I'm going to go up 5, and that will lead you to the points. So it's a pretty nifty trick to graph a parabola. If you know the vertex and you know the step pattern, you can graph the parabola fairly easily. So this is just kind of summarizing how to use it. You're always going over 1, over 1, up 1, over 1, up 3, over 1, up 5. So you'll see me do this a couple of times throughout this lesson. Next, we want to see what happens when we make some changes. So I have to apologize. This note, there was a mistake in the equations I wanted you to graph. So these equations, if you could correct them as you're working through this, it should not be y equals x plus 3 squared. It should be y equals x squared plus 3. There's a distinct difference here. One, in the original version of this, the 3 is within the brackets, whereas in this case, we want to know what happens when we add a number after the equation of the basic parabola. So the equation of the basic parabola is y equals x squared, and we want to know, well, what's going to happen if I add something after this? It could be a positive number, it could be a negative number. So what I did was I graphed these using a table of values. You could also have done this investigation using Desmos. So this is obviously what took me all the time to put this together, but basically I'm doing the same thing. I'm taking the standard set of values here. I would take -3, I would put it into this equation, so I would get -3 squared plus 3. So -3 squared is 9, plus 3 is 12. So that means that -3, 12, which is kind of off our graph, would be a point on this graph. So I did that for all these points, and I plotted it in blue. So the observation we want to take from this is, what do you notice from this graph? I'm not sure why these dots are here. They should not be here. I'll get rid of these. But what do you notice about this graph compared to, and I'll throw it up here just as a comparison, the basic parabola? These were the points of the basic parabola. What happened to this original parabola that is black? What happened to it to produce the blue graph? And if you look closely, you'll notice that every point moved up exactly 3. This point, 1, 2, 3. This point, 1, 2, 3. This point, 1, 2, 3. And this plus 3 going up 3 is not a coincidence. Because if you go to the original equation we're trying to graph, sure enough, look at this. You have a plus 3 at the end of this parabola. So the graph went up 3. So we also want to say, well, what if this was a -2 or a -5? What would happen to the graph of the original basic parabola? And if we use patterning and based on what we saw in the last example, this x squared minus 2, I did all the points for you, but we could probably guess that it would move down 2. It's not a plus 2, it's not going to go up, it's a minus 2. And sure enough, when I did all these table of values and I plotted the graph, it looks like you take every point on the original parabola and move it down 2. And that'll give you the new graph. So you're not going to have to or want to do this to graph. The whole idea of what we're trying to learn here is to avoid using the table of values. We want to now be able to look at this equation and just know right away what it's going to look like. Because if you can graph the basic parabola, which is this one with the 5 key points, and you know that this new parabola will go up 3, you just have to take this original parabola and move it up 3. Let's see if I can get the whole thing. You would move it up 3. For the next one, when you see the x squared minus 2, you just take this parabola, which you will know how to graph, and you move it down 1, 2, and you get the new parabola. So that's the end goal. That's what we're trying to get at. But in order to do that, you need to memorize these 5 key points of the original parabola and then know what effects adding or subtracting a number will do. So over here it just summarizes that the basic parabola will move up or down by the value that is either added or subtracted after the equation of the basic parabola. So there's other ways we could add or subtract numbers, and that brings us to our next example. And this time you'll notice a subtle difference here. The number is not outside, it's not after the equation, it is within the brackets. Instead of going x squared and then adding something, I'm subtracting or adding to x first and then squaring it. So there's a big difference, and we'll see what effect that'll have. So again, same process. I won't bore you with the details, but this time I strategically picked some x values to put in. Notice it's not the standard set. I just did that because I knew what the result would be. But if you took these values, subbed it into x, 1 minus 3 is -2, then you square it, you get 4. So that means when x equals 1, y equals 4, and this is what the graph looks like, 1 and 4. So I did that for all these values, and if we want to do a comparison to the basic parabola again, we'll try to see if we can determine what's happening here. So I'm just going to plot, those are the 5, this is how you would graph it. You would know these 5 points, You're going to say, well, how am I going to know those 5 key points? Well, you either memorize them, or you just go -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And that'll get you what I'm calling the 5 key points of the basic parabola. So what happened to this basic parabola that gave me the blue graph? Well, it's pretty obvious to see what happened here. It shifted over, not up or down, it shifted to the right. How many? Is it just some random amount? No. It went over 1, 2, 3. It went over 3 units to the right. So again, we're not going to be graphing using a table of values. You're going to be able to look at the equation and hopefully know the effect of the change that's, they call it a transformation, that's happening to it, and be able to make the new graph. Now you might say, wow, this is a -3. Shouldn't it go left 3? No. So in the last example, the added value moved it up, which kind of makes sense to us. The subtracted value moved it down, but it's the reverse in the left to right shift. So if you see a -3 here, it does not go to the left 3. It's actually going to go to the right 3. So if we look at our next example, which is x plus 1 squared, maybe before, I know you can already see it down there, but maybe now you could look at this, and if I was teaching this to you live, I'd say, well, make a prediction on what you think this is going to look like. And maybe you'd say, well, this moved to the right 3. Well, maybe following that logic, this might move to the left 1. And, I've taken the liberty of, going through the table of values again. Forgot to fill this part out. But sure enough, look what happened here. If you take the basic parabola and move it to the left 1, you get the new parabola. Right? So just let me fill these in now for you. What is the vertex of this new parabola? It's -1, 0. What is the direction of opening? It goes up. And then how do you determine the step pattern? Well, you can just count. Well, if I went over 1, look, I went up 1 to get to that first point. How many did it take to get to the second point? Up 3. So the step pattern did not change. And then I went over 1, up 5. So in summary here, the basic parabola is going to shift left or right by the value that is added or subtracted within the brackets of the equation of the basic parabola. There'll be a nice summary at the end of this. So hopefully, you get through this whole video. If not, go to the end, at least watch the last few minutes, and I'll summarize all these transformations. This would be a lesson that we would do in 2 days. So, well, this looks a little different. I've taken the basic parabola, and now I'm multiplying a number in front of it. And I want to know, well, what effect does that have? Now, I did make a mistake here with the values for x that I want to use, so I've kind of corrected that to the standard set. But let's see what happens when we multiply a number in front of the equation of the basic parabola. So same thing happening here. We're going to take the value of x that I'm interested in knowing about. I'm going to plug it into there. In this case, I would get -3. I would square it to 9 and then multiply it by 2, following the laws of BEDMAS. I would get 18. So that's off our graph. We can't go -3, 18's off our graph, so we just don't plot it. So again, I've taken the liberty of plotting all these for you. And sure enough, here's our graph. Now, it kind of looks like the basic parabola. You might say, well, that looks exactly like the basic parabola. But if I put the basic parabola back on this, you'll notice it looks a little bit different. The basic parabola is actually a little bit wider. Sorry if you can hear that in the background. That's my dog getting some water. She seems really thirsty. I think she's done. So this time it wasn't just a moving around of the parabola. What actually happened is it got stretched, but we don't really have to worry about that. We want to know, well, what's the change? Well, we'll observe the change when we fill out these pieces of information. So what's the vertex? 0, 0. It opens up. But what did change? It's the step pattern. So how did I go from the vertex, the original point, to the next point? I didn't go over 1, up 1 like the basic parabola. This time I went over 1, up 2. To the next point, over 1, up 1, 2, 3, 4, 5, 6. And then you can't tell, but I can tell off the table that the next one went up 10. So 2, 6, 10. Interesting, right? So, is it a coincidence that the step pattern is 2, 6, 10? And the answer is no. Because if I take the original step pattern of 1, 3, 5 for the original parabola, well, what happened to these values to get these new values in the step pattern? They all doubled. They all got multiplied by 2. And again, that 2 is not a coincidence. It's the 2, or the a value, that is sitting in front of the basic parabola. So if you can observe this value and you know what it is, you can multiply that by the 1, 3, 5 step pattern, and that'll give you the new step pattern. And if you know what the vertex is, then you can just start at the vertex and use the step pattern to make a graph. And you'll see a lot of that in the next lesson. I might have to do a video lesson for that one too, just because this stuff is not the easiest stuff in the world. Okay, so next example. Well, what's this going to look like? Well, you notice this is a minus number, so there's actually a pretty big distinct difference in this graph compared to anything we've seen. This is a parabola that actually opens downwards. So every parabola we've seen so far is just opened upwards. This is the first one that opens down. And again, that's not a coincidence. If you see that there's a negative number multiplied in front, that's going to cause the parabola to open down. And I verified that by doing all the table of values work for you. Now, without, I got these off the graph, but let's say I just wanted to graph this without any of this information. Well, what do I know about this? I know the original step pattern of the basic parabola is 1, 3, 5. What would the step pattern of this be, knowing what we just did over here? Well, I would guess I would just multiply these by -3. So 1 times -3, 3 times -3, 5 times -3. And this does work out to be the new step pattern. So if I know that the vertex is here, to get to the next point, look what I do. The negative indicates I go down. So I'm going to go over 1, down 3, and we're already off the graph, but to get to the next one, I would have gone over 1, down 9, and then over 1, down 15. Okay, so I know this is pretty overwhelming. It's a lot of content to throw at you in 20 minutes or so. I'm going to summarize it on the next page, but just stick with it. And again, this video you can watch it again. You can look up some other stuff on YouTube. You work through your notes. Just tough it out, and if you put in the effort, it will make sense to you. And again, reach out if you have any problems. So, in summary, we have the vertex form of a parabola. The general equation is this: y equals a, x minus h squared plus k. And these are the three, things that we did. Well, we added or subtracted a number here, we added or subtracted a number here, or we multiplied a number here. So in general, we call this an a value, this an h value, and this a k value. And what we wanted to observe is that this h value and this k value actually make up the coordinates of the vertex. So if you go back to all these examples we did, okay, if we go right back to the beginning, the h value is 0, the k value is 0, that's why the vertex is 0, 0. There is no h value here. That would be the first coordinate of the vertex. The k value is 3. So sure enough, my vertex is 0, 3. There's no h value here. The k value is 2. So my vertex is 0, 2. Or sorry, 0 minus 2, because this is subtracted. Going over here, well, there is no k value added here, so if we assume that's a 0, the h value is not -3, it's actually +3. So the vertex of this should be +3, 0, and it is. The h value here is -1, so this is -1, 0 as the vertex. So where we want to get with this is to be able to fill out a table like this. And I'm going to go ahead and work through a couple of the homework questions that are blank for you as well. But basically, if you are just given this equation, which might look intimidating to you, y equals 3x minus 7 squared minus 4. Well, if you break it down individually, you know the effects of these. What is this minus 4 doing? Well, it's going to bring the parabola down 4. What's this minus 7 within the brackets going to do? It's going to move the parabola to the right 7. And what's this positive 3 going to do? Well, it means it's going to open up because it's a positive value, and it's going to stretch the parabola, but it's also going to impact the step pattern. You're going to multiply the 135 by 3. So that's how you get these answers. So if you're looking at this, the parabola, the vertex of this parabola is going to be the opposite of this number. So it's -7 here. The h value is actually +7. And this value as is. So it's 7, -4. It opens up because this value here, the a value, is positive. And then the step pattern you're going to get from taking the original step pattern and multiplying it by the a value. So if I multiply 3 by this, I get 3, 9, 15. Over here, I can identify the vertex because I'm going to use the opposite of this value within the bracket. So it's going to be -44 and 6. It opens down because this is a minus here. There's no number here, so we assume it to be a -1. And if we want the new step pattern, it's going to be -1, -3, -5. And then lastly here, well, what's the vertex going to be? It's going to be the opposite of this number, so -2. And then this number as is, so you know your vertex. So if you know your vertex is, if you just very roughly, if you know your vertex is -2 and then way up here at 64, well, that's your starting point. And then if you know the step pattern, you take the 135 and multiply it by -2, you get -2, -6, -10. That's how you get to your next point. Over 1, down 2. Over 1, down 6. On that side, and then on that side. Same thing. So that's it for the lesson. I'm just going to peek at the homework here, maybe work through one with you that's kind of blank. Pick something here. I'm going to do this one. This is perfect. So actually, let me find one that has all three of them in here. Alright, this one's good. So I'm going to do this one. So with this lesson alone, we know a lot about this parabola. We should be able to identify the vertex now. So looking at this, I see these three values. All three of them are included here. So what's the vertex? I know by inspection now that it's going to be the opposite of that value. The h value is -5. So it's going to be -5, and then that k value, -4 as is. This is the x coordinate of the vertex, the opposite of it, and this is the y coordinate of the vertex. Now, does this open up or down? Well, this is a positive value, so it's going to open up. And then what is my step pattern? Well, my original step pattern is 135, and because that a value is 3, I'm going to multiply these by 3. So my new step pattern is going to be 3, 9, 15. So now I can put all this information together and make the graph. Ready? I'm going to plot the vertex, -5, -4. I know this thing's going to open up, and to get to the next point, I'm going to use my step pattern. So to get to the next point, I go over 1, and then up 3. Over 1, up 1, 2, 3. That's the next point. And then over 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the next one's going to be off the grid, so that's not going to work. And then we do the same thing on this side. Over 1, up 3, over 1, up 9. And that's how you make a graph of an equation that is in vertex form. So do your best to work through the rest of these examples. And again, listen, this is a lot of information. This would normally be taught to you over a minimum of 2 days. So well over 2 hours I would normally take to teach you this, and I just made a 25-minute video. So don't feel overwhelmed if it doesn't make sense at first. Just keep going back, keep watching it, and this is the main idea. If you can get to this point where you're just looking at this, identify the vertex, identify the step pattern, make the graph. So again, make sure you put in the effort on these questions and go from there. So keep checking the LMS for details daily, and again, I will try to make another video shortly. Take care.